Hello, this is geometry. In this video, we will jump into topic 6, quadrilaterals and other polygons. How are properties of parallelograms used to solve problems and to classify quadrilaterals would be our essential question of the topic. In this topic, we have 6 lessons total. We will start with lesson 1, the polygon angle sum theorem today. One example of applying our concepts that we learn in this topic would be honeycombs. We will learn a lot about different shapes, and one of them could be applied to observe honeycombs. Have you ever looked closely at honeycombs? What shape are they? How do you know? Most often the cells in the honeycombs look like hexagons, but they might also look like circles. Scientists now believe that the bees make circular cells that become hexagonal due to the bees' body heat and natural physical forces. What are some strategies you use to identify shapes? So think about real-world applications and other examples that you can come up with throughout the topic, but let's start with lesson 1. Oh, before we talk about lesson 1, there's another thing that you should think about throughout this topic. Here is the STEM project. Did you know that the Rhizoceros beetle of Central and South America can lift up to 850 times its own weight? That's equivalent to a 150-pound human lifting some 120,000 pounds or 30 cars. I can't do that. So that's really impressive. Your task for the STEM project when you're done with this topic will be designing a quadrilateral lift so that you can think about bus being able to lift as many people with safety measures and the best design. Okay. And you want to lift the bus so that you can use for the repairs. So yeah, so if you want to repair the bus, how would you best design the quadrilateral lift would be your task. All right, lesson 1, the polygon angle sum theorem. In this lesson, we'll be able to find the sums of the measures of the exterior angles and interior angles of polygons. Let's look at explore and reason. Start by drawing a pentagon. It doesn't have to be a regular pentagon. Draw any type of pentagon. Then for each side of the pentagon has 5 sides. Draw a line that includes the side. An example is shown. So after you draw a pentagon, you will draw the sides. You will draw an extension to the side so that it becomes lines. So let me draw my pentagon. Draw yours. Okay. Are you ready to see mine? So here, this is my pentagon. It has 1, 2, 3, 4, 5 sides. And I made all the sides look like a line, right? I extended the sides and they all are a line that could go on forever, that could stretch forever, this way and all the ways. The arrows represent lines. Okay, so make your own pentagon. Draw the lines by labeling arrows. Okay, part A, choose one pair of lines that intersect at a vertex of the pentagon. Vertex is just a point. is each of the four angles formed at the vertex an interior angle or an exterior angle of the pentagon. So choose one pair. So choose two lines that they intersect, and the intersection point would be a vertex, of your pentagon, right? I can choose these two lines here, and that's my vertex point. Is each of the four angles formed at the vertex an interior or an exterior angle? Is this an interior angle or an exterior angle? The intersecting lines form one angle inside the pentagon and three outside, right? 1, 2, 3. We don't just have one angle, right? We got four angles. The interior angle and the non-adjacent outside angle are vertical angles, so they're congruent. The interior angles form a linear pair with each of the two adjacent exterior angles. So interior angle is supplementary to each of the adjacent exterior angles. Okay, so by vertical angles theorem, again, these two are congruent and these two are congruent, right? So then, and the two other congruent angles would be supplementary to your interior angle because they form a line. Okay, so let's write that observation down. Okay, let me label the angles here. I'm gonna choose this vertical vertex, and I'm going to label the angles. That's my interior angle number 1. That's adjacent exterior angle number 2. That's my vertical exterior angle number 3. And then this is another adjacent angle in the exterior side. So to summarize, angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4 because they're vertical angles. And also angle 1 and angle 2 are supplementary. Angle 1 and angle 4 are supplementary as well. Okay. Part B, are the relationships in the same for the angles formed by the other pairs of intersecting lines? Would it be the same for the other vertices? Yes, so angle measures may vary, they could be different, but these two are vertical angles and these two are vertical angles, and these two form a linear pair. These two form a linear pair. So the relationship stays the same, right? So let's write that down in a different color. Yes, the angle measures may vary, but the relationships, oh, I'm running out of, are the same. Okay. Part C. If you drew a hexagon and the lines that included the sides of the hexagon, would the relationship between the angles at each vertex be the same as those in the pentagon? So we had a pentagon example. Would it be the same with hexagon? So try drawing a hexagon and draw the lines for all the sides and see the angle relationships. Okay, I drew my hexagon. Let me show you mine. So this was my pentagon, right? This blue figure is my hexagon. Looking at the angles, we still get these two vertical angles and these two vertical angles, and this interior angle will be supplementary to the adjacent exterior angles, right? They would be supplementary because they form one linear pair. And it's true for the other vertices. So does it matter if we have multiple sides or different shapes? No, there are some patterns, same patterns in the angle relationships. First, let's record what we figured out. So it'd be the same, yes. The relationship holds for a hexagon. And we can assume any angon. So, and possibly for any angon. Okay, and number of polygon. All right, so in this lesson, we'll think about how the number of sides in convex polygons. So convex polygons are the polygons that we looked at right now. Relate to the sums of the measures of the exterior and interior angles. Okay. Concave polygons would have different angles. So sides that go into your polygon, but convex polygons would all have interior angles to be less than 180 degrees. Okay. All right, example 1, explore polygon interior angle sum. Let's explore a little bit more. How does the number of sides of a convex polygon, n, relate to the sum of measures of its interior angles? First, you know that the sum of interior angle measures of a triangle is 180 degrees, right? Decompose polygons into triangles and look for a pattern. So think about what you already know about triangle. We're going to use triangles to see if there's any patterns. Okay. A quadrilateral, you can divide it into 2 triangles. Okay. When n is 5, so a pentagon could be divided into 3 triangles. Hexagon could be divided into 4 triangles. And then heptagon could be divided into 5 triangles. And any n sides of the polygon. Now, what's your pattern? Will be your n minus 2 triangles. There are n minus 2 triangles in every n-sided polygon. Each triangle has an angle sum of 180 degrees. So interior angle sum of an n-sided polygon would be 180 degrees times n minus 2. Okay. Because this is 180 degrees and that's also 180 degrees. So together it's 180 times 2 for that one, right? And same for the other angles. All of the angles of the triangles make your vertices for the polygon. So how many triangles you have, you multiply that by 180 degrees. And that's the angle sum of an n-sided polygon. All right, you figured out a pattern. Now let's look at try number 1. Part A. How many triangles are formed by drawing diagonals from a vertex in a convex octagon? And part B, what is the interior angle sum for a convex octagon? So using the pattern we figured out, can you figure out the answers for part A and B? Come back when you're ready for answers. Okay, so here's my octagon. How many triangles are formed? Octagon has how many sides? 8 sides. And so looking at the pattern, you should have how many triangles? 8 minus 2, 6 triangles. Draw the diagonals. Okay, so that's 1 triangle, 2 triangle, 3 triangle, 4, and 5 and 6 triangles, right? All right, so 6 triangles. What is the interior angle sum for a convex octagon? So using this formula, 180 times 6 is 1,080 degrees. So the interior angle sum of a convex octagon would be 1,080 degrees. Cool. So here's a theorem. Polygon interior angle sum theorem says the sum of the measures of the interior angles of a convex angon is 180 times n minus 2. And we explored in example 1, y, right? This is y. So if you have 1, 2, 3, 4, 5, 6, 7 measures of angles, then 180 times 7 minus 2 is 900. That's a heptagon. Corollary to this theorem, which means there's another theorem that could be made from theorem 6.1. The measure of an interior angle of a regular angon would be 180 times n minus 2. That's the total angle divided by n. Right? Because if it's regular, all the angles should have the same measure. So if it's not regular, you can't do this, but this only works for a regular angon. Okay, so if we have a regular pentagon, 1, 2, 3, 4, 5, n is 5, then measure angle 1 would be 180 times 5 minus 2, which is 3, divided by 5, and that's 108. So all the angles of a regular pentagon would have a measure of 108 degrees. Okay. All right, example 2. Let's apply the Polygon interior angle sum theorem. Jenna is building a corner cabinet to fit in a rectangular room. If she builds it with the angles shown, how can she determine whether the cabinet will fit? Okay, so what polygon would this be? 1, 2, 3, 4, 5. It's a pentagon. So draw a pentagon to represent the cabinet. Find the sum of the interior angle measures of the pentagon. And then you can subtract the known angles to determine whether the corner angle is a right angle. Okay. So because rectangular room would be a 90 degrees angle in the corner, right? So you want this cabinet to be exactly 90 degrees angle. You know, these two are 90 degrees, right? So figure out the total angle of the interior angles, and minus 2, 5 minus 2 is 3. 3 times 180 is 540. So that's the total angle, 540. And you know these angles. So if you subtract all these angles, you would get your unknown angle. So 540 minus 90 and 135, and 90 would be 90. So the unknown measure is also 90 degrees. So the cabinet will fit in the corner. If not, I would say you can put it in here. It's kind of, maybe it's hard to open the door. Or if you put it in a corner like this, you could just open the door only 90 degrees. So that's fine. You can still get in. But anyway, if you want this to be the front and you want to see if this angle fits, then you would have to figure out if that's 90 degrees. All right, try number 2 on the next page. What's the interior angle sum of a 17-gon? So looking at your theorem, figure out the interior angle sum of 17 gun. It's gonna be a big angle. Okay, part B, each angle of a regular angon measures 172.8. How many sides does the angon have? So first, figure out the sum of the interior angles, and then if the regular angon has 172.8, how many sides does the angon have? Use the equation and the formula to figure out the n, okay? So come back when you're ready. You ready for A and B? A, you have to use the Theorem 6.1 Polygon interior angle sum theorem. You can multiply 180 times n minus 2. So 180 times 17 minus 2 would be your answer. And that is 2,700 degrees. Whoa, that's a lot. Okay. And then you don't know what angon this is, but each interior angle measures 172.8. How many sides does the angon have? How do you figure this out? You know it's a regular polygon, right? So you're going to use theorem 6, the corollary theorem to 6-1, and the measure of interior angle, which is 172.8, would be equal to 180 times n minus 2, the total angle divided by n. And we don't know what n is, but it's okay. We know what each angle measure would be. So we just need to figure out the n using algebra. So then what do? First, you multiply n on both sides so that we can get rid of this denominator. N divided by n, they cancel out. So you have 172.8 n is equal to 180 times n minus 2. Let's use the distributive property to distribute this out. 172.8 n is equal to 180 n minus 360 degrees. And then you see the like term, 172.8 n and 180 n. So I wanna keep them positive. So I'm gonna subtract 172.8 n on both sides. And I'm gonna add 360 on both sides so that you have 160 on this side and it's positive. Okay, and so 180 minus 172.8 would be what? 7.2 n. And if you divide 160 by 7.2, that is your n. What is it? 7.2 goes into 360 15 times. So how many sides does this regular polygon have? 50 sides. It's an 50gon. Whoa. It's almost gonna look like a circle, but it has a lot of sides. All right, so now you know how to use the theorems. Let's go to example 3 and understand exterior angle measures of a polygon now. What's the sum of the exterior angle measures of a convex polygon? You can use what you know about the sum of the interior angle measures of convex polygons to find the sum of the exterior angle measures. So by exterior measures, we mean one side of the polygon and the extension of an adjacent side form an exterior angle. Okay, so this is one side of the polygon. The extension of an adjacent side, so extension of adjacent side would be this one. That's exterior angle. One side, extension of the adjacent side. And you have to go the same way. You can't do, oh, what about this extension? No, let's go the same way. Each interior and exterior angle pair forms a linear pair which measures 180 degrees. So the sum of the measures of n interior and exterior angle pairs would be 180 times n because they're linear pairs, right? So, and you have n times the linear pair because that's just how many angles you have because of the sides, right? So you can say sum of exterior angle measures is equal to sum of interior and exterior angle measures, which is 180n, minus sum of interior angle measures, which is 180 times n minus 2 using our theorem, right? And then solving that and simplifying gives us 360 degrees. Coincidence? I think not. So the sum of the exterior angle measures of any convex polygon is 360 degrees. Okay, so try number 3. What's the sum of exterior angle measures of a convex 17gon? Any convex polygon has an exterior angle measures of 360. So does it matter if it's 17gon or 36gon or 50gon? No, the sum of angle measures would always be of any convex polygon would always be 360 degrees. Okay. So again, does the number of sides matter when finding the sum of exterior angles? No. Okay. Sum of measures of exterior angles of any convex polygon is 360 degrees. Easy. So theorem 6.2 says exactly that. Polygon exterior angle sum theorem says the sum of measures of the exterior angles of a convex polygon, one at each vertex, not double, is 360 degrees. Cool. Example 4. So let's use that exterior angle theorem and find the exterior angle measure. Suppose measure of angle 1 is congruent to angle 3. Okay, they're congruent. And measure of angle 1 is equal to 3x. Okay, that's 3x. So that's also 3x. And measure of angle 2 is 2x. This is 2x. Okay, what is the measure of each exterior angle? Okay, so you know that exterior angle 5 is a right angle, exterior angle 4 is a right angle. So remember, we have to have one exterior angle at a time. So let's say we're gonna go this way, like clockwise, okay? So we're measuring this angle and that angle is 2x, and then this angle, right? That's exterior angle, and then this angle and that angle. So we have, starting from 1, we have the sum of exterior angles should be 360, right? So 3x plus 2x plus 3x, because they're vertical angles, that could also be 3x, and they're vertical angles, so that could be 90. And then 5 is 90, would be 360 degrees, right? So then you can add the like terms. 3 plus 3 plus 2 is 8, 8x, and 90 plus 90 is 180. So subtract that from 360, you get 180 equals 8x. And x is 180 divided by 8, which is 22.5. So x is 22.5. What is the measure of each exterior angle? Now you know the x, you can figure out 1 and 2 and 3. 4 and 5 are 90 degrees, so they're already given. 1 and 3 are 3x, so multiply 22.5 by 3, you get 67.5. So that's the measure of angles 1 and 3. Measure of angle 2 is 2x, so multiply 22.5 by 2 to get 45 degrees. Now you figured out the measure of each exterior angle. Done. Let's look at try number 4. Suppose angles 1, 3, 4. Wait, yes, 4, 6 are congruent. 1, 3, 4, 6 are congruent. And 2 and 5 are congruent. So 2 and 5 are congruent. And 3 is equal to 2 plus 30. What is measure of angle 4? So figure out the measure of angle 4 using the exterior angle, sum of exterior angles theorem. Okay, see if you can do it by yourself. Come back when you're ready for answers. Okay, so remember, think about exterior angles in the same way. So if you're going clockwise, angle 1 is correct, angle 2 is correct, but 3 is not the right exterior angle. 3 has to be this, but they're vertical angles, so that's fine. And 4 is same, but 5 also has to be here. 6, we're also counting this one, but they're all gonna be the same measure. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 would be the sum of exterior angles. Okay, so you know that they all have to be adding up to 360 degrees, right? So let's say if angle 1 is x, 3 is also x, 4 is also x, 6 is also x, right? So that's also x. So 4x, 1, 2, 3, 4x plus 2 is going to be, with 2 and 5 are going to be congruent, but 3 is, wait, let's go the other way. I'm sorry. It's going to be easier if we say x is 2. Or we can say, you know, we can say x minus 30, but let's put 2 and 5 as x. And then we have 1 and 2, because 2 and 5 are x. 3 is going to be what? X plus 30. So that's x plus 30, that's x plus 30, that's x plus 30, and so on. You have 4 angles that are x plus 30 and 2 angles that are just x, right? And they have to add up to 360 degrees. Let's figure out what x is. 4 times x is 4x. 4 times 30 is 120. 2x is just 2x. Combine like terms, 4 plus 2 is 6x. And 360 minus 120 would be 240. So x would be 40 degrees, right? So then what is angle 4? Angle 4 is equivalent to angle 3 and 1, which is going to be x plus 30, right? So measure of angle 4 is x plus 30, which is 40 plus 30, which is 70 degrees, okay? And angles 2 and 5 are just 80 degrees. Wait, yeah, they're just 40 degrees. And then all the other angles are 70 degrees. All right, let's look at example 5. Find the measures of interior angles. What are the measures of the interior angles of the Pentagon shown? So use the Polygon interior angle sum theorem. This has 1, 2, 3, 4, 5. So it's a pentagon. It should have n minus 2 triangles, right? So 5 minus 2 is 3. So 3 times 180 would be 540. And if you add them all up, it should be 540. And so this plus this plus this plus this plus 90 is 540. So you write the expression, combine the like terms, and solve for x. X is 20. And then you can substitute the value of x to find each angle measure. 6 times 20 minus 3, 3 times 20 plus 4, 7 times 20 minus 3, 6 times 20 plus 12, and so on. And you can figure out all the angles with that. So it's 90, 117, 64, 137, and 132. Let's see if you can do try number 5. The measure of each interior angle of a regular Pentagon, wow, is 3x plus 26.4. It's a regular Pentagon. What is the value of x? So here, what can you use? The formula for the regular polygon would be n times 180 times n minus 2 divided by n, right? And that's equal to 3x plus 26.4. So you can figure this out by substituting n is equal to 100. So write your expression again. 3x plus 3x plus 26.4 is 180 times 100 minus 2 over n, which is 100. Okay, so I'm going to, what am I going to do? Let's simplify the right side. 3x plus 26.4. 100 minus 2 is 98. And 180 times 98 is 17,640. Divided by 100 would be 176.4. So 176.4 minus 26.4, 176.4 minus 26.4 is 150 is equal to 3x. 150 divided by 3 is 50. X is 50. Okay, so use the theorem we learned. So let's summarize our lesson. Polygon angle sums. Theorem 6.1 says any type of polygon has an interior angle sum of 180 times n minus 2, where n is how many sides your polygon has. Theorem 6-2 says polygon exterior angle sum theorem says that the sum of measures of interior angles of any convex polygon would be 360 degrees. Okay, so that was our lesson 6-1, the polygon angle sum theorem. That was fun. Let's continue with the next lesson. 6-2 would be about kites and trapezoids in the next video. Thanks, guys. Bye. Ask Ms. Kang if you have any questions. Bye.